Hello, this is Coldcrazylogic, and today we have a geometry problem. It says determine the radius of the inscribed circle in a triangle with the side lengths 6, 25, and 29. And this is from the individual round of the JV Rockdale math competition, and it's problem number 7. So without further ado, let's go ahead and get right into the video. Before we jump into the problem, let's look at this formula right here. This formula is used to find the area of the triangle given an inscribed circle. And what an inscribed circle really is a circle that is bounded by the edges of the triangle. And to put that into simpler words, that is basically a circle that is inside a triangle and the corners touch the edges of the triangle. Now let's get into the formula. So the formula says area is equal to r times s. R standing for the radius, which is the radius of the inscribed circle. And s standing for the semi-perimeter. And that is basically half the perimeter. So let me write those things down real quick. Okay, now that we have this, let's jump into the second formula we need to solve this problem.
Okay, but before we go on to the second formula, I wanted to explain that there are many ways to find the area of the triangle. This is just one of them. And you would use this formula to find the area of the triangle when you're given the radius of the inscribed circle and you're given the sides of the triangle, since you need the sides to find the semi-perimeter. Alright, let's continue the video.
Okay, let's take a look at the second formula we have here. This formula is called Heron's formula. And basically it says that the area is equal to the square root of s times s minus a times s minus b times s minus c. So this formula and the previous formula both work for any type of triangle, which is the beauty of it. So like we can find the area of this triangle if we're just given the sides. And like I said before, s stands for semi-perimeter, which is basically half the perimeter. And this is what it looks like if you write it out. So looking back at the formula, it's the semi-perimeter times the semi-perimeter minus a, which is one of the sides here, the semi-perimeter minus b, which is another one of the sides here, and the semi-perimeter minus c, which is another one of the sides.
Okay, so to elaborate, you would use this formula when you're given three sides of any triangle, and that's when it would work.
So now, let's go back to the problem we had at the beginning of the video. Okay, I'll give you a quick second to read the problem again. Okay, so the first thing we want to do with any geometry problem is draw a diagram. So let's draw a diagram of an inscribed circle in a triangle with side lengths 6, 25, and 29. Okay, so now that I'm done drawing the diagram, let's look at the first formula that we went to. And that is A is equal to R times S. Skip back to the timestamp in the video description for more information on that. So what we can do with A equals R times S is we can rearrange it, since we need to find the radius of the inscribed circle. So if we divide by S on both sides, we should get R is equal to A over S. And this is how we're going to find the in radius of the circle. So now that we have that, we just need to find the area of the triangle and the semi-perimeter. Okay, so to find the semi-perimeter, we just do 6 plus 25 plus 29 over 2, since that's the perimeter over 2. So 6 plus 25 plus 29 over 2 is equal to 60 over 2, which is equal to 30. So that's our semi-perimeter. So let's go plug that into our equation. And to find the area of this triangle, we just have to use Heron's formula, which is the square root of the semi-perimeter times the semi-perimeter minus a, the semi-perimeter minus b, and the semi-perimeter minus c. So the semi-perimeter times itself minus all the sides. So now that we have the semi-perimeter is 30, we just plug that in. And we have the side lanes. And you can put them in whatever order you want. It doesn't really matter. So we have 30 times 30 minus 6, which is 24, times 30 minus 25, which is 5, times 30 minus 29, which is 1. Okay, so all we have to do is multiply this out using some quick tricks and we'll be fine. So if we prime factorize this into its roots, we get 3 times 2 times 5 for 30. For 24, we get 3 times 2 cubed. For 5, we leave it as 5, and for 1, we don't do anything. So now let's just combine these terms. So 3 times 3 is 3 squared. 2 times 2 cubed is 2 to the 4th. And 5 times 5 is just 5 squared. Now we can apply the square root to this, and the squares cancel out. So 3 squared just becomes 3. 2 to the 4th, which is 2 squared, just becomes 2 squared. I know that sounded confusing, but just go with me here. And then 5 squared, the square root of 5 squared is just 5. So now we can just distribute this, and we get 3 times 4 times 5, which is just 60. And now we have the area of the triangle, which is 60. So let's just plug that back into here. And we get 60 over 30. And now just simplifying this, we get the answer of the in radius, which is just 2. So that's all for this problem actually, because all we had to do was find the in radius using A and S. So if you like this video, please leave a like down below and subscribe for more fun problems just like this and fun math tricks that I have on my channel. I'll try and post videos more frequently from now on.
Hey guys, just a quick little update on the channel. First of all, sorry for not posting that much in the last 4 months or so. I've kind of gotten used to my schedule now, so I will likely be posting a new video every 2 to 4 weeks or so. Thanks for understanding.
But until the next video, stay crazy.